Do you remember a couple days ago, maybe not, maybe last week, when I talked about how we can use Desmos on the star, right? Yeah. The feature? Okay. And I was going to try to be more cognizant to show you the cheat codes with it now that we're in the spring and I've taught you what you needed to know and now we can cheat code some things, right? All right. So let's look at the warm-up. There's a few things I'm going to look at. All right, number 1, find the solution to the systems of equations. So there's 2 ways to solve systems of equations. Brian, right now is the time to turn around and listen. One of the 2 ways is what?
Elimination.
Ooh. Elimination and substitution. Elimination, both expressions have to be in standard form. Substitution, they need to be in y equals, correct? Okay, or x equals, just an isolated variable. Alright, so let me show you a life hack to systems of equations that you're very much going to enjoy. The only thing is I need to get both of these in slope-intercept form. So if you solved them out, good deal. If you didn't remember how to do systems of equations, we're going to do a cheat code. Alright, so if I'm trying to get, if I'm going to balance y to be by itself, right, I'm going to take x from both sides. Do you agree? So I have negative 2y equals negative x plus 4, yes?
Yeah.
And if I'm continuing to work and get y by itself, I would divide by 2, correct? And then I would divide each term over here by 2. Now I have y equals, what does it mean when I have that x over 2? What is that actually representing? 1/2. Okay, because this x has an invisible coefficient of 1. So when I put the 1 and the 2, it bumps the x to be at the side. So a negative and a negative make a positive. So I'm going to have a positive 1/2 x. And then positive divided by negative gives me a negative 2. Yeah, I have that. Okay, so that is the y equals equivalent. Do you agree? Okay. For the next one, 4th period used this, so I'm going to switch it up for you guys. Alright, so in 4th period, they manipulated standard form to get the y equals. They didn't balance for y. So they said slope. How do you find slope off of standard form? Negative a over b. How do you find y-intercept? C over b. Okay, we're going to ask that again. How do you find y-intercept out of standard form? C over b. Okay. Alright, so if I label my letters A, B, C, so my slope is a negative 2 because no matter the a value, it will be a negative a over negative 1. So my slope is what? 2. Positive 2. And then C over B, C is negative 1. B has an invisible coefficient of negative 1. So it's 1. So it's positive 1. So I could write this y equals 2x plus 1. Do you agree?
Okay, yeah.
All right. Now here's where I want you to pay attention.
Pay attention, Angel.
Reagan, you've been the one paying less attention than Angel has.
That's not true.
That is true. You were solving to make sure you were still correct during my first explanation. Feeling a little spicy today. I'm in a good mood. I'm just a little spicier today. All right. So here's what I'm going to show you. We can use Desmos to our advantage. And in the spring, I like to start using things to our advantage because the STAR test isn't to see what you know. The STAR test is to play a game and outsmart the game. So I'm going to help you outsmart the game at this point.
Okay.
I know what you know. All right. No. So this right here, Desmos testing with a green bar at the top. You can use this on the STAR test. It will be accessible. This will be accessible on your benchmarks. Last week we used it for transformations, yes? Mm-hmm. We typed in the parent function and the translated and saw the change. We did. So now I'm going to type in, what's the first standard form equation?
X minus 2y. X minus 2y equals 4.
Okay. When I type in standard form, does it graph it?
No.
So what do you think the only caveat to this system is?
Y equals.
Has to be in y equals. So if I convert both of my systems of equations to y equals, type y equals 1 over 2 x minus 2. 2x plus 1, do I clearly see their point of intersection? And if I even click on it, it will literally tell me. So what that means, systems of equations just represents where two lines intersect at a given point. The point, -2, can be plugged into this x value and get out -3, and -2 can be plugged in here and get -3.
Plug in -3 and get -3?
Also didn't think I got the same answer.
Okay, so you could have used substitution or elimination. I want to show you a way to either fact check yourself or just cheat code the whole thing.
So if we did this, would we still have to show like?
That was gonna be my next point. So I asked this in 4th period. I said, can you use this on warm up? And they all went, they didn't know what to answer. You can. What do I want to see if you're using it on warm up?
Work.
What would be work?
Putting you solve it.
Putting in the y equals. Okay, making the slope intercept would be your work for it. Okay, so what I want you to do, I'm going to give you 3 minutes. I want you to open up your computer and open up Desmos, it's at the top, and I want you to try number 4. Okay. Even if you solve number 4, put it in y equals so you can get the feel.
That was the easiest one.
Number 4? So you will get there because it is posted at the top of your Google Classroom. It is not in a topic, it is living at the top of your class. Click Texas.
Texas. You do not have that type of accent. You can't believe that. You don't have an accent.
Is that it has the green
You
bar.
have to
There's
try.
one with the blue bar where it'll grab all of them.
British.
Alright, so make those bottom two equations y equals and type it into the Desmos and see what it's going to look like. So you get to practice it before it's all you.
Why is my dividing sentence so
Brandon, today might seem a little excessive for you. But I agree. What do we get number 2? What? Good. Nope. It is technically correct, but it isn't technically correctly written. Bum bum bum. What? Alright, so put those bottom two equations in y equals. You can balance for y, or you can do a over b, c over b, and put it into slope intercept like that.
Oh my, what word can I see me?
It will be fractions. Yeah, you're correct. You want to know a fast way to do fractions? So type your negative into your numerator. So then you don't have to go back. It's the same as on teacher me. You can just backslash to make an automatic fraction. It's life changing.
Oh,
There you go,
whoa.
Tyler.
Whoa.
Whoa, whoa, whoa! You're foreshadowing the lesson today, Jacob.
What? Oh!
Whoa!
I don't know. What? I don't know what's happening. It's doing it immediately.
Okay, pause. Tap out.
Yeah.
There you go. Now put your X. There you go. Oh. Because you're putting X.
I got it. I didn't.
Miss Grigsby, I just barely click it and it puts it twice. Oh. I swear.
So
I got it.
how do you do fraction?
Type your numerator. You got it? You sure that's your numerator?
I'm not gonna lie, I don't remember what it is number 20.
The top one?
I keep asking this kind of
Well, that is. Okay, I'll take it. You can just walk away.
I keep clicking backspace. Miss Grigsby.
I know I'm about to lose you.
I barely click it and it just
Dash.
Oh, I think I know what happened.
And then top out.
I can tell you how to fix it.
It's fine. Miss Grigsby, I barely click backspace. Look how much it
I know how to fix that, I'm just not gonna tell him.
What do you tell me?
No.
What do you tell me out loud?
No.
Alright, what did you get for the first y equals? Brandon Tate. My money goes to you.
Y equals 2x plus 1.
Okay. Alright. Do y'all agree with Brandon?
Yeah.
Alright, Triple Wolf, what do we get as the second equation? We're gonna wait until you can tell me.
Y equals negative 1/5 x 2/5.
Minus 2/5? Okay. When I graph both of those, do I get a point of intersection?
Yes.
What is
Yeah.
Negative 2, 0.
I'll give you
it?
all that.
-2, 0.
So, technically, I have one,
You
right?
didn't, not with the business. Alright, so you can use this to your advantage on warm-up. I do want you getting a feel for it. The only thing with warm-up is with Desmos, you have to put it in what form? Y equals form.
Then x.
Okay.
Most definitely.
Alright, here we go. So, looking at number 2. So apparently Reagan was told this is the worst lesson ever, no one understood what she was talking about. First thing, I feel like people did know what I was talking about with this one. Second thing, the second half of our day you're learning something new, so I don't expect anyone to be an expert by the time you leave. Do I ever expect you to be an expert? No. I literally tell you, you learned it 5 minutes ago, I don't expect you to know it. Do I expect you to try?
Yes.
That's where the people in 4th period have their misunderstanding. Also, do you want to hear a scary story?
Yes.
Sure.
We'll act like it's Halloween. Did you know? I'm just putting you on blast. Just putting you on warning. One of my 6 classes has been given a seating chart now.
Ours.
Was it 7th or 8th grade?
7th grade.
Of course.
So
it's not 8.
but the whole class was given a seating chart. They did not like it. So, just check yourself, people. Alright, here we go. I'm gonna nerd out on this lesson really quick. Close your computer doors. Go ahead and put your warm-up away. No, don't put your, we're going over number 2, don't put it away. Just close your computers.
I'm like, okay.
So now Taylor Swift's gonna go to the background because Grigsby's gonna start talking, right?
Yeah. Did you
Yeah.
say Taylor Swift?
Yeah, because that's what is playing in Reagan's ear. And whatever is playing in Brandon and Tripp's ear also will
I
go
don't have
away.
any uploaded actually.
Okay.
That's fine.
Just Brandon. But not Brandon anymore, because we're gonna really take in today's lesson. Yeah, Brandon?
I think he still has it.
Oh.
I took a really long time to turn around to give him the grace to, every time I do this. Okay.
It was 11.13.
You gotta clear it.
It's not loading.
Are you struggling?
1, 2,
I am
5, 7.
so much struggling. This is so anticlimactic to the
Are
lesson.
we being recorded?
You are, because I have forgotten in other classes. Plus, you just my favorite class. Oh my gosh. Thanks.
Yeah, we're just being taught the best.
Yes.
You should tell them when we finish class.
Okay.
You
They
learn
can
from
hear
your
us.
mistakes.
Actually, my favorite class will depend on who can answer my question in 13 minutes. I'm going to tell you that.
I'm ready.
Because first period could not answer it, and I told them I will ask my 5th period, who is my favorite class. So that question will be dependent on.
Wait, did they answer it?
First period could not, 4th period did.
Okay.
So, alright, here we go. Looking at number 2. When we did exponents originally, I taught you what you needed to know, and I left out the trickier stuff because your brain wasn't ready to have the capacity to take it. Does that make sense? I needed you to learn the basics. Now we're going to use the basics and go a little bit more. Do you think that's why I'm probably teaching number 2 to you?
Yes.
Yeah. Alright, so I think I have mentioned, so if I have an exponent outside, that means I'm multiplying it, right? I'm multiplying this to these, correct?
Yes.
Okay, so I would have x to the what? So 6 times 1/2 is 6, just 6 divided by 2. 3. And then I'm going to get y, 7 divided by 2.
3.5.
3.5.
That's impossible.
That's why Tyler gulped. Alright, and then 8 times 1/2? 4.
4. Why are there so many fractions?
Okay.
Well, that's
So
stupid.
yes.
I thought you do the 128 too.
I do also do the 128. I want to make a point though. Have I ever had decimals in my exponents?
No.
Yes.
He is true.
No, he is tripping. Alright, so when I do the 128, I need to say, I would type it in my calculator like this, right?
Right?
Alright. 128 to the 1/2 power is the same as what?
11.313708499.
Square root 2 square root of 128.
The square root of 128. Angela gets a lollipopper. Don't leave without it, I will forget. Alright, so these two are equivalent expressions, right? So if I type it in, 128, what the tarnation?
Oh my gosh, it's
128
8499.
to the
1/2 power.
oh my gosh. Alright, I'm just gonna do the square root of 128.
1002.
I'm having Jacob's conundrum. Alright, I get that, right?
11.313708499.
So the square root of 128 is, I would say, rounded, right? Have we had situations where the coefficient was a decimal?
Oh, yes.
No, we have not. Alright. We're going to imagine Jason is tripping this whole class and we're just going to tune him out. So here's the new piece of the lesson. Here's the new piece I hadn't taught you, and here's the new piece where your brain is not going to like it, but once we do some more of it in different warm-ups, you're going to understand it. Let me ask you this. If you get 8/10 as an answer, do I accept 8/10?
No.
No. What do I accept?
0.8.
Simplify. Or
What
would it be as a fraction?
0.2.
What?
What are you talking about?
Whoa.
4/5.
Brian, stop, drop, and roll. You were on fire and about it. Alright,
His brain's on fire.
is 4/5. Do you agree?
Yeah.
So, in our mathematical world, I don't accept 8/10 as the answer. I accept 4/5. Is 8/10 technically correct?
Yes.
Yes. But it'll tell you wrong, because you want simplified, right?
Yeah.
Alright, what I'm going to do, anytime I square root a number, and it's not a perfect whole number, I want to simplify the radical. That's what that's called. Simplify the radical. Okay? In order to simplify the radical, what I want to do is I want to take 128. Now, here's where also I didn't teach this during exponents because there's some other things we need to keep in mind. Think about perfect squares. I want to find which perfect square, or what perfect square can divide out of 128. So, what are our perfect squares? So, our first perfect square is 4, right?
Yeah.
Because if I take the square root of 4, I get what?
2.
2. So that makes 4 a perfect square. What's the next perfect square in our
9.
sequence? 9.
15.
Hold on. 9, because if I square root 9, I get 3, right? Alright, we're going to go in order. Brian said 16 is the next perfect square. What's next?
25. 49. 64. 81.
Someone beat Jacob.
100. 121. 144.
And we're going to stop it there. Alright. So, I am not solving the square root of 128 down. Solving it would get me 11.31. Not solving it. I'm simplifying it. Okay? So I want to find, if I'm taking the square root of 128, I want to know what perfect square times something equals 128. So, we're going to think about divisibility. Do you think, I'm going to start at the first. Do you think 128 is divided by 4? I'm going in a process. Because I bet you $20.
Yes.
If I didn't lead up like that, like on number 3, if you divided by 2, that's not the divisibility. It's 4.
Number 3 on the test?
On your map. If I don't lead you up to know to look for something higher, you don't. So imagine just letting me teach my lesson.
True.
It is divisible by what? 4 and
32.
32. Is it divisible by 9?
No.
Try it. You expect it to be no. I want you to prove it to be no.
No.
128.
Is 128 divisible by 9?
No.
Alright. Is it divisible by 16? Alright, here's the thing about
Yes.
division. Yes, it is divisible by 16.
8.
Thank you, Tyler. Alright, I want to know the highest perfect square that it's divisible by. 64? Try it. Do it. 128 divided by 64.
Yeah, it is.
I get
2.
Okay. Just for funsies. Try 81. Is 128 divisible by 81?
I wonder if it is.
No, it's
No. Alright. So watch this. The square root of 128, I can multiply the square root of 64 and the square root of 2. Really, I'm just saying, I will send you out of my room. If you do not want to listen, which I'm looking more toward the back of my room who has not been listening and talking every time I turn around, you 3 are about to get assigned seats and Tyler will be set free. Alright.
Release Tyler.
I'm not going to do it today. I have too much to cover for y'all to not pay attention.
Set Tyler.
Alright, so the square root of 64 and the square root of 2 equal up to 128, correct?
Yes.
Out of those two, is there something I could square root?
Yeah.
64, 2, right? I can square root 64, yes? And I get 8. However, I can't square root 2 to a perfect square.
Nope.
So, what I've done, so this is the simplified radical.
What did we just do?
Did I tell you we were solving it?
Yeah.
I said we were what?
Simplify.
Simplifying it. Alright. So if I type in my calculator 8 times the square root of 2, oh, not 8 squared. 8 times the square root of 2, I get 11. I get the same thing.
11.313708499.
So the square root of 128, we could write it. Yeah, we could. Let's see. But if I want to write it in its most simplified version, I would say 8 times the square root of 2. So I found the perfect square it was divisible by.
You're gonna make us start simplifying things.
If you have, you're very rarely going to see this. And at the time we learned exponents, your brain wasn't ready to take it in. Your brain kind of is now because we've learned perfect squares, we've learned exponents. You will rarely see it, but I was going to teach you.
You are occupied.
It's the same as saying 8/10 is equal to 4/5. That's just what we did. Your brain's not going to like it, but when we see it in more warm-ups, you think I'll still go through those with you. Yeah, until you finally learn it. So, what I do, so my answer to that is I'm going to write the 8 and the square root of 2. Okay, that's going to be part of my, now we said x to the 1/2 was x to the 3rd, right? And y to the 1/2 is the same as y, the square root of y, right? And because it came out as a decimal, I'm going to put y with the 2 under the square root house.
Okay.
Because anything that's a decimal doesn't square perfectly, so it would just stay in the square root. And then z squared perfectly, so I'd say z to the 4th. So this right here would be my answer for number 2.
8x.
Your brain probably doesn't like it. Your brain doesn't understand the lesson.
I understand.
That's alright, because me and Jason are vibing. He's no longer tripping.
So when we when it isn't a perfect square, we put it in the house without the exponent on the inside.
I may forget the perfect squares instantly as soon as you leave them.
I figure as much.
Perfect squares are easy.
I
Yeah.
can't remember them though.
If perfect squares are easy, why isn't simplifying radical easy? Because it's just using a perfect square.
I think
It's just a lot of work.
It is.
I already have a headache.
Okay.
A lot of perfect.
Alright. We are going to go dive into my lesson now. That wasn't even the lesson.
What about number 3?
I can't speak English.
I'm not doing number 3. Number 3, factor something out and it's a perfect square. It's a difference of squares.
I can do that.
I remember how to do this.
What's the difference of square?
I can answer this.
Whoa.
In your opinion, what color is this paper?
Blue.
Teal.
That's what I said.
I don't
The
know, I
debate
partially
has been
colorblind.
serious. I would go back to your space and you don't need to face them to do the next debate.
Set Tyler free.
Imagine all those missing assignments might be missing for a certain reason like that. Ah, so scary.
I think you forgot.
I'm only missing one.
What?
I was missing
You got one?
I'm not missing any.
I have a 0, but I still have an
If that test isn't complete, that 0 will drop you to below
I know.
70.
Wait a minute.
80. I only have 3 questions, and I don't know how to do 2.
Okay, so let's go. A linear function. We have only dealt with linear functions last year in 7th grade and this year up until this point. What does linear make you think of? Line?
Linear.
Straight line. So we have dealt with linear functions. Linear functions being straight lines. Okay? Now, there's a thing that we reference called parent functions. Yes? Have you heard me mention?
Yes.
Okay, so parent functions are just the most basic form of something. So in straight lines we've dealt with, slope intercept, standard form, point intercept, whatever, it all starts with this. So the most basic parent function of linear functions is y equals x. That's it. And in this table, when I input y, or when I input x, I get an output of y. It mimics. If I input -2, I get an output of -2. If I input -1, I get an output of -1. Just for funsies, let's find the rate of change here. -2 does what to become -1?
+1.
-1 to 0?
+1.
0 to 1?
+1.
1 to 2?
+1.
So, in a parent function, yes. In a parent function of a linear function, the slope is always 1. It always passes through the origin. So, let's prove the y's. -2 to 1 adds 1. -1 to 0 adds 1. +1, +1. So, if I did change in y over change in x, my parent function has a slope of 1. And when we graph parent functions, if we were to graph the linear parent function, it would look like a straight line that goes straight through the origin. I go over 1, up 1, over 2, up 2. And then I want you to put your pencil down once you have that.
Can the slope of the parent function
I found the answer to number 3.
No.
What about the degrees of?
I feel like this is a teaching moment for me. I'm getting places, I'm going places. Alright, so that's our parent function. To put this in relation, if I were to change the slope that's not 1 and make it 2, that makes the slope steeper, right? And when I give the parent function a y-intercept, that takes the line up or it takes it down, right? So everything we've done with slope, all we're doing is adjusting or modifying y equals x. That's it. We either change the slope to make it steep or less steep, or we add a y-intercept to take it up or to take it down. Yes? Alright. What we're going to look at now is, we got to talk about the degree. Now that we've learned exponents,
I have it.
I know that every exponent has an invisible 1. So would you agree that this parent function we've looked at for the past 3 years has had an invisible 1 you've never realized?
Yeah.
Yeah.
Okay, but what about the question that you were going to ask from 13 minutes ago?
Wait for it, it's coming. Thinking about polynomials. When we have a big strand of polynomials, I always say you write the exponents in order of their highest exponent to the lowest exponent. So we look at it in the highest degree to the lowest degree. So this function is a degree of 1. When it's asking degree, it's talking about the exponent power.
So this would be 2.
Hold on. So before I started really yapping about quadratics, I wanted you to know the basics of linear, which is what we've been working on the past 2 years. Now for the fun stuff. Alright, a quadratic function, first off, is y equals x squared. So we're actually squaring the value. Therefore, it would have a degree of
2.
2. Ooh. Alright, and our quadratic function is no longer a straight line. It's a curved U-shaped line. Here's the question that could make you or break you as my favorite class. I have used the term, there is a special name for that U-shaped graph. I'm going to give you the same hint first and fourth guy.
Oh my god,
Polynomial.
parabola.
Parabola. I told first period y'all would be my favorite. And I, Jacob Porter, will give you $5 interest. That's what I put on the line in fourth period.
Doesn't he already have
And
3?
yeah, be built different like him.
How you spell that?
Because in fourth period I said $5 interest for this question because I didn't bet that they would know it, but they ended up knowing it. So someone did get $5 interest. However, in fourth period we had to play hangman for them to get it. So they had the P-A-R-A, then someone guessed it. So a parabola. A parabola is the U-shaped graph. It's going to be U-shaped.
My handwriting on that is really good.
Alright, now let's look at the table of a quadratic function. Brandon Tate, this is where the lesson will seem excessive. I would write it down. Looking at my x's, -2 does what to become -1?
+1.
-1 to 0?
+1.
Okay.
+3.
Alright, now for funsies, let's look at my y's. 4 does what to become 1?
Minus.
Okay, -3.
Oh.
1 does what to become 0?
Minus.
Are you with me? You with me? Okay. 0 does what to become 1?
Plus.
1 does what to become 4?
Plus.
And 4 does what to become 9? Okay. So in the linear function, it had a constant rate of change happening, correct? Okay. Does my quadratic function have a constant rate of change happening? No.
That's better.
It has a pattern. Alright, now I want you to put your pencil down, if you have that written. What do you notice about my y values?
Their change.
They go up and down.
They go up and down, but like how?
The rate of change goes up and down.
Goes -3.
It decreases and then...
Increase.
Okay. So on a quadratic function, your y values decrease, then increase.
Is the
And then put your pencil down. Because when I said put your pencil down before, I forgot to do that piece. So the next part is something I do want you to just take in my knowledge. Alright. So quadratic functions have a degree of what? 2. Alright, I'm gonna ask that again. We're gonna act like Aleda and Tripp weren't the only ones that knew that. Quadratic functions have a degree of 2. Okay. Aleda, I think they just cheated off of you. Alright, so do not write. Are you gonna write with me?
No.
No. Are you gonna pay attention?
Yes.
Are you gonna zone out? Probably. Pretend like you're not. -3 does what to become -1?
+2.
+2.
We're adding on.
-1 does what to become +1? -1 or +1 does what to become +3?
+2.
3 adds 2 to become 5. So, because quadratic functions are a degree of 2, the constant rate of change happens in the second layer. So, full circle, right? Crazy. Now you can write that down, and we're gonna write, we're gonna say rate of change.
Rate of change, right? Rate of change.
Rate of change happens in the second layer. So if you were given 2 tables, or you were given a table and asked, does this represent a quadratic function? You'd find the rate of change, and then you'd find the second rate of change happening on the y value.
Rate of change.
The rate of change of rate of change.
I'm not even speaking English.
Isn't that so cool how the pattern has a pattern?
Rate of change squared.
What are we learning?
The rate of change is rate of change.
What's the title of your highlight page say?
Quadratic function.
Ah.
Wow.
Alright. So the next little yapping session I'm gonna have, before we start looking at the graphs of quadratic functions, you need to know the vocabulary. So I'm gonna talk at you with the vocabulary and then we'll go Bible it.
We're supposed to talk with.
Yeah, but no one's talking with me. So
I am.
talking true. Aleda is too. Alright, so there's 4 pieces of a very important vocabulary. A lot of quadratic problems are going to be vocabulary based. So you have the axis of symmetry. What does the word symmetry mean to you?
They're the same on both sides.
Same on both sides. Alright.
Parallel.
Is this symmetrical?
No.
Would this be symmetrical?
Yeah.
No.
Yes. Would this be symmetrical?
No.
Would this be symmetrical?
Yes.
Okay. Beautiful kindergarten lesson, right? Better than math for one. Alright, so symmetrical means same on both sides. So when I have an axis of symmetry on my parabola, it would be a line that cuts the graph straight through the middle. Okay? And I forgot to take off that vocab word. So it's going to be a vertical line that passes through the vertex. And you can outline that because it's kind of fake on yours.
What?
It cuts the parabola in half. So this is like its own second point.
Because the answer was like right there.
Yeah. And then the equation, when I write or represent the axis of symmetry, think about this. If I draw a vertical line on a graph, I draw a straight up and down line. What axis does it hit?
Y. X.
I drew a line straight up and down. What axis
X.
does it pass through?
X.
It passes through X. So my equation would start with X equals. So the equation would be X equals a number.
It also could hit the Y axis.
It could, but it will always hit the X.
But what if it's above the X? Then would it hit?
But the x's goes.
What if it just like starts above the X and it doesn't go below?
Jason, stop.
Alright, vertex. It's going to be the lowest or the highest point. Of parabola. And we could also refer to it as the minimum or the maximum. Whew, that was a lot to write.
You think anyone knows this is parabola?
Parabola?
Parabola.
So your vertex is the highest or lowest point on a parabola. And your vertex is determined or related to concavity. I don't know the proper pronunciation. Concavity. But the word concave reminds you of cave. Nah, what?
Conservation.
A cavity.
You learned this in science. You're the first class to hesitate on this.
Cake.
Concave, convex. Concave means to
Conduct.
Subduct.
dent. Like indent. A concave means to like dent
I
down.
never learned that.
Yeah, I don't know about that.
Y'all are first class to hesitate on this. I didn't teach you, but you've learned it in science.
No,
Did
no,
we?
not at all.
I would remember. Jacob doesn't even know.
First period knew it.
But Jacob doesn't know it.
But first period knew it.
But maybe they're cheaters.
They listened to my lesson ahead of time somehow.
I knew
Alright.
what it meant. I just
Now
didn't
he
know
knew
the
what
word
it
you
meant.
wanted. I didn't know the word you wanted.
Alright, so if it concaves up, that means our graph will be pointed upwards. It will be pointing up and the dent is at the bottom.
So it'll be like that.
Mm-hmm.
Wait.
Meaning it's like a U facing upward. And our vertex is at the minimum point.
Is minimum.
So if it's going
Is
down.
minimum.
Okay, so if it concaves up, that means my arrows are pointing upward. It's just a traditional positive. Vertex is at the minimum or the lowest point. And on the flip side, if it concaves down,
Okay, I thought of it.
so concave down would look like this.
Maximum.
Vertex would be your maximum point.
The up has a U and the down has a N.
True. Totally true.
That's a really good
And
Alright, I got 2 minutes.
Ugh, ah, screams.
So, solutions. When we've dealt with linear functions, we've had how many solutions to a linear function? One, right? And a linear
Yeah.
function hits the x-axis how many times? Once. Okay. With,
Parabolas hit it
oh
twice.
my gosh. With quadratic equations, it's a degree of what? 2. So I could hit the x-axis in how many spots?
2.
At 2. I could hit once, I could hit 0. But your solutions are the point where it hits the x-axis. Point where it hits the x-axis. And solutions could be called 3 different things. They could be referred to in 3 different words. You got to know they all mean the same thing. So a solution to a quadratic function, if it's asking you for a solution, all it's asking for is the x-intercepts.
Oh, couldn't it also be called 0?
Yes! Jelly popper for Reagan. Yay!
Oh.
I'm handing it out like candy today.
Did you just say Jolly Pop?
Yes. And so x-intercepts also represent your zeros. And then the next word, I don't know where it came from. I don't know the relation. I don't know why they chose it. But another word for a solution on a quadratic function is called the roots.
What?
Roots.
Roots.
Yeah, that's right.
So if I'm asking for roots, I'm asking for the x-intercept. If I'm asking for zeros, I'm asking for the x-intercept. You may now pack up.
Oh no.
I saw